So the other day we talked about surface area of prisms and cylinders. Today we move on to pyramids and cones. Now pyramid is basically a polyhedron, meaning three-dimensional, right? In which one face can be any polygon and the other faces are, and in this case you'll see, are triangles. So when you look at the base, right? The base is just any polygon, right? So when we look at this one's a hexagon. Okay, but all of these lateral faces that you see here, right? All of these lateral faces are in the shapes of triangles now. So the difference between a prism and a pyramid is a prism had rectangles as lateral faces, a pyramid has triangles as lateral faces. Okay, so when you look here, you have your lateral edges, which are basically where two faces meet. But then you have to understand you have all of these triangles meet at a vertex, which is the point where all the triangles intersect. Now, from there, you have your lateral faces, which are your triangles, right? Then you have your altitude. Now, this is the tough one. Your altitude is what goes from the vertex perpendicular to the middle of the base. And then you have your base edge right here. Okay? Now, there are two different types of heights for a pyramid. The first height is called the actual height, and this actual height goes from the vertex to the perpendicular to the base. Okay, the second one is called a slant height, and this is actually the height, right, of the triangular, right, lateral face. And that's important to know because this, right, is the slant. The slant height is what we need to know in order to find the surface area of this pyramid. Okay, so you have to know the difference between the height and the slant height. So now, when you have your slant height, right, you have to see a couple of things here. When you break this down, you will see that this right triangle is formed. So sometimes you may have to use Pythagorean theorem to find the slant height. And in the future, you might even have to use Pythagorean theorem to find the height. Now, the lateral area is basically the sum of the areas of all the triangular lateral faces. Okay, so when we look at this, you could actually find the area of each triangle and add them all up. But we could also do what we call like the formula. So the lateral area of a pyramid could also be the perimeter of the base times the slant height L, all divided by 2. And the reason we're dividing by 2 here is because when you're doing the perimeter of the base times the slant height, you got to remember the area of a triangle is base times height, all divided by 2. So we say the lateral area of a pyramid is basically the perimeter of the base times the slant height, all divided by 2. And then the surface area would just be the lateral area of the pyramid plus the area of one base. Okay, let's take a look at a couple of examples here. So this first example, you're given a pyramid. In order to find the the lateral area of this, right? Remember, I can find the area of one triangle multiplied by 4. I can find the area of each triangle and add them up, or I'm just going to find the perimeter of the base, find the slant height, multiply and divide by 2. So the perimeter of the base here would just be 60 times 4, which would be 240. So we would do 240 times. Now for my slant height here, I have to actually use that Pythagorean theorem we talked about. So if this is the center of the base, I know this is going to be half the side. So if the whole side is 60, this is going to be 30. So now we can use Pythagorean theorem. 30 squared plus 40 squared equals the slant height squared. And if you know the triple, your slant height would just be 50. So 240 times 50, all divided by 2, right, would give you 6,000 meters squared. Okay. Now, the area of your base, on the other hand, right, the base is a square, so the area of the base would just be 60 times 60, which gives you 3,600. So the total surface area would be the lateral area, right, plus the area of the base. So 6,000 plus 3,600 would give you 9,600 meters squared. And that would be the surface area of your pyramid. Now, the next one. This one's a little tricky because what they're giving you here is they're actually giving you the lateral edge. Okay, so they're giving you that side there, which is 13. Now we know this is a square base, so we know this side is going to be 10. So what we're going to do now is we're actually going to draw. So if that's 13, you know this is 13. So I'll actually draw it in the front here so you can see it better. When I draw that slant height in, I know this piece is going to be half the base, so that's 5. This piece is 13. So now if I call this my slant height L, now I'm going to use Pythagorean theorem here, right, using this triangle to find the slant height. So slant height squared plus 5 squared equals 13 squared. And if you solve for this, you would get your slant height is 12. So now I can find the lateral area. So the perimeter of the base is 10 times 4, which is 40. So we're going to get 40 times 12, all divided by 2. Okay, 40 times 12 divided by 2 gives you 240 centimeters squared. That would be your lateral area. Now the area of the base here would be just 10 times 10, which is 100. So now we can find the surface area to be 240 plus 100, which is 340 centimeters squared. Okay. So this next example, right away, the first thing I'm going to do, everything here is already here for you. You have to know what you have and know how to use it. So right away here, the perimeter of the base, you can see the length of each side is 6, right? The perimeter of the base is 6 times 6, which is 36. They already tell you the slant height is 9. So right away, the lateral area would just be 36 times 9, all divided by 2, right? And that would give you 162. Now, the area of the base, you have to realize that that is a hexagon. So you know it's the apothem times the perimeter, all divided by 2. Well, the apothem is 3 root 3 times the perimeter is 36. When you multiply that and divide it by 2, right, you're just going to do 36 times 3 divided by 2. That's going to give you 54 root 3. And now, when you go to find the surface area, right, that's just going to be 162 plus 54 root 3. Now, these cannot be combined as is, right, but you could put that in the calculator to find the approximate value. So 162 plus 54 square root 3 would give you 255.5. And that would be inches squared. So that's your surface area. And here's your lateral area. Now a cone, very similar to a pyramid, but the only thing is you have to understand that a cone, right? The base is a circle instead of a polygon. Very, very similar though. The vertex, right, is basically the peak, right? So here would be your vertex. It also has an altitude, which is basically the altitude and height are the same thing. It goes from the vertex perpendicular to the circular base. And then the slant height basically goes from the vertex to the base edge. So right here, when I look, this would be your slant height. Now, when you unwrap or undo a cone, if you think about it, like a snow cone, like if you undo the wrapper, what does it look like? Well, that wrapper, when you undo it, basically looks something like this with a circular base, right? So now, when we look at that, right, you know you're going to use the slant height for this, okay? And then the base of it, this here, is basically going to be the circumference of the base. So your lateral area, what I like to say, they give you a formula up there. I think the easiest way to remember it, it's the circumference of the base times the slant height, all divided by 2. Okay? Now, they shorten it here to pi times the radius times slant height, right? Because if you do the circumference of the base, you're just dividing the 2 pi r formula by 2, and it leaves you with pi times radius times slant height. I think this is just a little easier to remember. And then the surface area is just the lateral area plus the area of the base. So, looking at this to find the surface area of the cone in terms of pi, first thing we're going to do is find the lateral area. So the circumference of the base here would just be 2 times pi times they give you the radius here is 15. So the circumference of the base is just going to be 30 pi. Now, if the circumference of the base is 30 pi and your slant height is 25, your lateral area is just going to be circumference of the base 30 pi times the slant height of 25, all divided by 2. And when you do that, you get this would be 375 pi. Okay, so now the area of the base, remember it's a circle, so it's going to be pi times radius squared. So pi times 15 squared would give you 225 pi. And now my surface area is going to be my lateral area, 375 pi, plus the area of one base, 225 pi, which gives you 375 plus 225 would give you 600 pi, and that would be centimeters squared. Okay. Next one. Here, it's a little more complicated because what you're given here is you're given, right, the height, not the slant height. So first thing I'm going to do, find the circumference of the base. If the diameter is given to you as 4, circumference is just going to be diameter times pi, which is 4 pi. Now, what you have to remember here is this is 2, that's 4.5. I'm going to use Pythagorean theorem to find the slant height. So 2 squared plus 4.5 squared equals the slant height squared. So when you go ahead and figure that out, you end up getting a slant height, which is equivalent to the square root of 24.25. So now my slant height is the square root of 24.25. And now my lateral area is circumference of the base times the slant height all divided by 2. Now, since you get the square root of 24.25, this is one where I would just go ahead and find the decimal value. So I'm going to plug that in the calculator exactly the way I see it. 4 times pi times the square root of 24.25. That gives you approximately 61.88. And when I divide that by 2, you end up getting a slant or the lateral area of about 30.9. And the surface area would then be that 30.9 plus the area of the base. If you think about it, the radius is 2. Pi times 2 squared is 4 pi. So take that, add the 4 pi, and you get about 43.5 meters squared. Okay, so looking at all of this, cones tend to be like cylinders, pretty easy to figure out. So let me know if you have any questions, and I will answer them.